Our solar system, a cosmic ballet of planets, moons, and asteroids, each moving in its own unique path, began its journey billions of years ago, in a time when the universe was still young and full of potential. It all started with a vast, cold cloud of gas and dust, known as a nebula, floating silently in the cosmic void. Imagine a giant cloud, much larger than our solar system is today, filled with tiny particles like specks of dust and molecules of gas drifting aimlessly. This cloud was mostly made of hydrogen and helium, the simplest elements in the universe, remnants from the Big Bang, the very birth of our cosmos. Over time, something disturbed this peaceful cloud, perhaps the shockwave from a nearby supernova or the gravitational pull of a passing star, setting off a chain reaction. As the cloud collapsed under its own gravity, it began to spin faster and faster, like a figure skater pulling their arms in during a spin, conserving angular momentum. The spinning motion caused the cloud to flatten into a disk, much like a spinning ball of dough flattens into a pizza crust, setting the stage for the formation of planets and other celestial bodies. As the solar nebula continued to collapse and spin, gravity pulled most of the material towards the center. This central region became denser and hotter, much like a bicycle pump gets warm when you compress the air inside. The pressure and temperature became so intense that hydrogen atoms began to fuse together, forming helium and releasing a tremendous amount of energy. With the ignition of nuclear fusion, our sun was born. Even in its infancy, the sun's powerful gravity held the spinning disk of gas and dust in its sway. The birth of the sun marked a turning point in the evolution of our solar system. While the sun was bursting into life at the center of the solar nebula, the remaining gas and dust in the disk were not just idly circling. Instead, they were engaged in a complex dance of collisions and clumping, driven by gravity and the rotation of the disk. Some of these clumps grew large enough to exert their own gravitational pull, attracting more gas and dust and growing even larger. These clumps became the seeds of planets, growing like cosmic snowballs rolling downhill. Close to the sun, where temperatures were scorching, only heavier elements like rock and metal could condense into solid particles. Further out, beyond what we call the frost line, temperatures were cold enough for volatile compounds like water, methane, and ammonia to freeze into ice. Within the protoplanetary disk, a remarkable transformation was taking place. The tiny grains of dust and ice, remnants of the original nebula, were gradually coming together, building the planets we know today. This process, known as accretion, is like building a house brick by brick, except on a cosmic scale. These larger particles continued to collide and grow, eventually becoming kilometer-sized planetesimals, the building blocks of planets. As planetesimals grew larger, their gravitational pull increased, attracting even more material from the surrounding disk. Over millions of years, these planetesimals continued to collide and merge, gradually clearing their orbital paths and growing into protoplanets. As the planets continued to grow, they began to differentiate, separating into distinct layers based on the density of their materials. In the inner solar system, where temperatures were high, the planets were primarily composed of rock and metal. As these planets accreted material, their interiors melted, allowing denser materials like iron and nickel to sink to the center, forming a metallic core. Lighter materials such as silicates rose to the surface, forming a rocky mantle and crust. These planets, Mercury, Venus, Earth, and Mars, became the terrestrial planets characterized by their solid surfaces, relatively small sizes, and higher densities. In the outer solar system, beyond the frost line, temperatures were cold enough for ices to remain frozen. By this point, our solar system was a chaotic and crowded place. The young sun, now a powerful force in its own right, began to flex its magnetic muscles. As the sun's nuclear furnace roared to life, it emitted a powerful stream of charged particles called the solar wind. This solar wind swept through the solar system, pushing against the remaining gas and dust in the protoplanetary disk. Like a cosmic leaf blower, the solar wind cleared away the leftover debris from planet formation, leaving behind a much cleaner and less crowded solar system. The planets themselves, especially the giant planets like Jupiter and Saturn, played a significant role in shaping the solar system's final architecture. While the planets were taking shape and the solar system was being cleared of debris, other celestial objects were also forming. Moons, those faithful companions to planets, emerged from the leftover material orbiting some of the larger planets. Some moons likely formed from the accretion of material within a planet's gravitational influence, much like the planets themselves formed around the Sun. Asteroids, those rocky remnants from the early solar system, represent material that never quite made it into a planet. Most asteroids reside in the asteroid belt, a region between Mars and Jupiter where Jupiter's gravity prevented the formation of a planet. Comets, those icy wanderers of the solar system, formed in the outer reaches, beyond the frost line. The early solar system, while less chaotic than before, was still a dangerous place, teeming with activity and potential hazards. The planets had cleared their orbital paths of most debris, but a significant number of planetesimals and other objects remained, posing a threat to the newly formed worlds. These remnants of the solar system's formation were like cosmic bullets, constantly on the move. This period, known as the Late Heavy Bombardment, is thought to have occurred roughly 4.1 to 3.8 billion years ago. It was a time of intense and frequent collisions, reshaping the surfaces of many celestial bodies. During this time, the inner solar system experienced a dramatic increase in the number of impacts from asteroids and comets. These impacts were not just minor collisions, they were cataclysmic events that could alter the course of planetary evolution. These impacts, some of which were incredibly powerful, left their mark on the surfaces of the planets and moons, creating craters, canyons, and other geological features that we can still observe today. The scars of these ancient collisions tell a story of a violent past. The Late Heavy Bombardment was a defining period in the early solar system's history. It played a crucial role in shaping the planets and moons, influencing their geological and atmospheric development. After the tumultuous Late Heavy Bombardment, the solar system gradually settled into a more stable configuration. The planets, having cleared their orbital paths of most debris, settled into their current orbits, and the rate of impacts from asteroids and comets decreased significantly. This marked the end of the solar system's formation and the beginning of its long, stable existence. The Sun, now a mature star, continues to bathe the solar system in light and heat, providing the energy that drives weather patterns on Earth and sustains life as we know it. The solar system, once a chaotic cloud of gas and dust, has transformed into a well-defined system of planets, moons, asteroids, and comets, all bound together by the Sun's gravity. The story of our solar system's formation is a remarkable one, a tale of cosmic evolution spanning billions of years. From a diffuse cloud of gas and dust, gravity orchestrated a symphony of events, culminating in the formation of the Sun, the planets, and all the other celestial objects that make up our cosmic neighborhood. It's a story of collisions, of growth, of destruction, and ultimately, of creation. As we've explored the key stages of this epic journey, we've gained a deeper appreciation for the intricate processes that shaped our cosmic home. We've learned that our solar system is not a static, unchanging entity, but rather a dynamic system with a rich and complex history. The formation of our solar system is just one chapter in the grand story of the universe. This story spans billions of years and encompasses countless events that have shaped the cosmos as we know it today. As we look out into the cosmos, we see evidence of star formation and planet formation happening all around us. These processes are ongoing, creating new stars and planets that may one day host life. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope have captured stunning images of protoplanetary disks, providing us with glimpses into the early stages of planetary system formation. These images help us understand the conditions under which planets form and evolve. These observations have revealed a remarkable diversity of planetary systems, with planets of different sizes, compositions, and orbital configurations. Some planets are rocky like Earth, while others are gas giants like Jupiter. Some systems have giant planets orbiting very close to their stars, while others have planets in highly eccentric orbits. This diversity challenges our understanding of how planetary systems form and evolve. As we continue to explore the universe, we will undoubtedly learn even more about how our own solar system formed, and about the countless other planetary systems that likely exist throughout the cosmos. Each discovery brings us closer to understanding our place in the universe and the potential for life beyond our own planet.
Like and subscribe to start your journey today.